Hi everyone! In this video, I will be showing you guys how to do different types of difference quotient examples. And on the side, I will have a list of steps for you guys to follow along. These steps can be used in any kinds of difference quotient problems. I explained the background of the difference quotient in the previous video, so if you guys want to watch that, there will be a link in the description box. So let's get started. Our first function is f of x is equal to x squared minus 2x plus 5. So the first thing that we want to do is to find f of x plus h. A way we can do that is by simply plugging in x plus h into every place that we see an x. Because in f of x plus h is our input. So let's go ahead and substitute x plus h wherever we see an x. So we have x plus h squared minus 2 times x plus h plus 5. I put parentheses around the x plus h to know that we are substituting that in. And now let's actually try to simplify this a little bit. We have x plus h squared. Remember that x plus h squared actually means x plus h times another x plus h. And that's by the property of exponents. So now we can bring down the negative 2 times x plus h plus 5. Before bringing everything else down, let's actually distribute this first. We can multiply x with x, that's x squared. X with h, that's plus xh. And then h times x, that's plus xh. hx and xh are actually the same thing because of the commutative property. We can write them in whichever way. Plus h times h, which is h squared. What we can also do is distribute this negative 2 inside of the parentheses. So if we multiply negative 2 times x, we get negative 2x, and negative 2 times positive h is negative 2h. Because remember that whenever we're distributing, we have to distribute to absolutely everything inside the parentheses. And now we can bring down the positive 5, plus 5. So this is our f of x plus h, and we just completed our first step. Our second step is to plug in our f of x plus h that we just found and our original f of x and plug those two into the f of x plus h minus f of x all over h function. So we can take our f of x plus h. X plus h and x plus h are like terms, so let's actually combine those two. If we add them, we get plus 2xh. So we can substitute that. Minus our original function and divide that all over h. Remember that we have to put parentheses around the original function because that was a whole thing. And the next step is actually to distribute out the negative. If we distribute the negative sign, we have a negative times a positive, that is a negative, so we have negative x squared. Negative times a negative, that's positive, so we have positive 2x. A negative times a positive, that is also a negative, so we have negative 5. So now we can simplify some things. X squared minus x squared, that cancels out. That's negative 2x and the positive 2x cancel out, and so do the two 5s. So we're left with 2xh plus h squared minus 2h all over h. If you guys notice, in the numerator, we have all the terms with an h. Since all the terms have an h, we can factor out an h. And if we factor out an h from each term, we're left with 2x plus h minus 2. And that is all over h. And if you guys remember how to simplify, h divided by h is 1, so they go away. It's like an invisible 1 that appears. And what our final answer would be is 2x plus h minus 2. This is as far as we can simplify, so this is our final answer. Let's try one more. If we have f of x equal to 1 over x, we again first have to find what our f of x plus h is. So if we compute f of x plus h, remember all we have to do is again substitute x plus h wherever we see an x. So the only place that there is an x is in the denominator. So our f of x is 1 over x plus h. Now let's plug it into the difference quotient formula. So we have 1 over x plus h minus 1 over x all over h. This is something called a complex fraction. If you guys have taken algebra, you guys should remember that in order to get rid of a complex fraction, what you can do is multiply it by the LCD. One easy way of getting rid of everything would be by multiplying the LCD over 1. In this case, our LCD is x plus h times x. Because here the denominator of h is 1, so we don't really need to worry about that. So we can take our LCD over 1 and multiply to every term in this fraction. If we look at each case individually, we can actually see that things cancel out. For example, this x plus h cancels out the x plus h in the denominator. In this case here, the x cancels out the x. And in the denominator, nothing cancels out, but that's okay. So let's rewrite our answer so that we have everything that is left over. The only thing that didn't get canceled out is our x, and we have a minus, and we also have an x plus h that is left over. And all of that is being divided by h times x plus h times x. So this process actually made all of the denominators cancel out, and we're left with a nice fraction, somewhat nice fraction. What we can do now is keep on simplifying. So we have a negative on the outside, so what we can do is distribute the negative onto the inside of the parentheses. So once we do that, we're left with x minus x. Positive times a negative is a negative. So we have minus h all over. I won't simplify the denominator just because I want you guys to notice something. So we have h times x plus h times x. And here, if you guys simplify the numerator, in the numerator, you have an x minus an x, so that is actually canceled out. All we're left with in the numerator is a negative h, and that's all being divided by an h times x plus h times an x. One thing that you will always notice about difference quotient is that your h's will always cancel out. You may still have 1 or 2 left, but you will usually cancel out some sort of h. So in this case, the h that we can cancel out is the h in the numerator and the h in the denominator. We can't cancel out the h inside the parentheses because it is inside the parentheses. It's not exclusive. It's attached to the x by addition. So we can only cancel things out if the operation is multiplication. So our final solution is actually going to be negative 1. It's negative 1 because division divides h divided by h, and that's negative 1. And that's going to be all over x plus h times x. So this is our final solution. These kinds of problems may be tedious, but they all follow the same procedure. You first have to find f of x plus h, and then plug f of x plus h and f of x into the difference quotient, and then just simplify as much as you can until you cannot simplify any further. I hope that helped. Make sure to hit the subscribe button to get the latest videos.